Okay, in this video we're going to take a look at 3 additional graphs to just look at the other 3 functions that were on that front page. First thing, again, we're going to want to list out the transformations and also think about what is the parent function here. So our parent function is going to be f of x equals x squared. There's not a space for this here, but there will be on your homework or your practice worksheet, which we'll be doing in class. Okay, so first we have the negative sign. That's a reflect over the x-axis. Now, in terms of transformations, you can do the reflect over the x-axis and the vertical stretch at the same time because it both involves multiplying. So the 3, is a vertical stretch by a factor of 3. The x plus 2 is going to be a translate left 2. And the plus 5 will be a translate up 5. So we want to do that first piece at the same time, right here. And that's just going to be a multiply by negative 3 on your y column. Original table, always important to start with. Now, I think I recall in the test, I'm not going to have you list out the transformations, although it's helpful. Knowing what these do to the tables for this section is what's important. So negative 2, negative 1, 0, 1, 2. And then this is squared, so it's going to be 4, 1, 0, 1, 4. Remember, you're using the same x values for all 3 of the 4 functions. The square root is the only one that's different. So we're going to multiply the y column by negative 3 right away. That's going to take care of the reflect and the stretch at the same time. Notice that table is the same table. Okay, and then we're going to do our transformation stuff, which is our second part here. Those we can do at the same time. So we're going to, left 2 means we're going to subtract 2 from the x column, up 5 means we're going to add 5. So we'll get our final table, then we can plot points and connect. We'll get negative 4, negative 3, negative 2, negative 1, 0. And those are easy because they go by ones once you figure them out. And then this is symmetrical, so we're going to get 7, 2, 5, and then 2, 7 again. And that's your final table. We're going to plot those points. Now, I didn't go with my same strategy of plotting the vertex, which is 1, 2, 3, 4, 5, making this a little bit trickier. Oh, apologies. Those should be negative 7s. Before we start graphing this, negative 12 plus 5 is a negative 7. So let's start with negative 2, 5. 1, 2, 3, 4. That's going to be the highest point on our graph. That's going to be your vertex. And then we'll do negative 3 and 2. And across from that will be negative 1, 2. And then negative 4, negative 7. And 0, negative 7. Points came off their spot a little bit. And then you're going to connect it with a U shape. I know the other one was the V shape. Just make this one look a little curvier. There's a tendency to make this kind of look like a V also. You just want to make it curvy on the top. So notice the process is the same, just a different graph. All right, we're going to take a look at the square root one next. So again, the table's going to be a little different. This one for your original table, we only have a couple values here. We have 0, 1, 4, and 9. So think when you're setting this table up, your perfect squares, and then the square roots of them. I didn't give myself enough space to show what to do next, but we'll get there. Now, one important thing that's happening here, I would just rewrite this equation. Factor out the negative sign on the inside, because that's going to give you the correct horizontal translation. If you don't factor it out, that's going to mess you up. Our parent function is f of x equals square root x. So we actually have, in this case, the negative on the inside is a reflect over the y-axis. You're going to actually multiply your negative, the x values by a -1. The x minus 1 is going to be a translate right 1. And the -3 is going to be a translate down 3. Okay, so first thing we're going to do is we're going to make all of the x values negative because you're going over the y-axis. Here's your y-axis. If you reflect over that, it's the x values that will change. It's kind of the opposite value than what's in the sentence there. Everything else stays the same. So we're going to do translate right 1, which is adding 1 to this column, then translate down 3, subtract 3, to get our final table of 1, 0, negative 3, -8, and then -3, -2, -1, and 0. So it's the right column that goes down by ones. This last one doesn't fit, which is okay. If that happens to you on any of these, just don't plot them. This will give us enough to kind of see what's going on. Okay, so we're going to put on 1, -3. These you will want to plot in order, 0, -2. Wrong way. I don't know what I'm doing here today. 0, -2, -3, -1, and then 1, 2, 3, 4, 5, 6, 7. We could kind of squeeze 8 on off the graph if you want to try to get it on there to see where it's going. If not, you just kind of sketch it that way. Again, make it a little curvy. Shouldn't just be a line where you're connecting the dots here because these graphs aren't linear. And our last graph will be the cubic function. This one doesn't have any stretching going on, but it does have a reflection, so our negative on the outside is a reflect over the x-axis again. The x minus 3 is going to translate at right 3. And the plus 2 is going to be a translate up 2. Again, we want to list our parent function is f of x equals x cubed. So that's not a transformation, that's what the function is that we're working with. That tells you what original table to start with. So we're going to start with the table of -2, -1, 0, 1, 2. So like 2 of the other ones, we're cubing it, so it's -8, -1, 0, 1, and 8. First thing we're going to do is make our y column negative, or actually switch the signs in our y column. And then we're going to add 3 and add 2 because that's our two translations. If we do that, we end up getting 1, 2, 3, 4, 5. And we're going to get 10, 3, 2, 1, and -6. Now these should all fit on this graph because we made this a little bit bigger. So we have 110 up here. We have 2 and 3. We have 3, 2, 4, 1. So you'll notice the middle points on this get kind of close together, and it's the later ones that stretch out. 1, 2, 3, 4. And then to get this, you want to kind of curve it. It's a little tricky. Get it a little curvy in the middle, facing up on the top part and down on the bottom part. And that's it. So this gives you kind of an overview of how to use the transformations with the 4 different graphs. and you will be doing plenty of practice, so these are good ones to look back at. And the front sheet, the tables, again, do need to be memorized.